Algebra 2, state sample question number 15. Given z of x equals 6x cubed plus bx squared minus 52x plus 15, if z of 2 equals 35 and z of negative 5 equals 0, algebraically determine all the zeros of z of x. Well, right here, when they say z of 2 is 35, they're saying when x is 2, y is 35. And z of negative 5, 0, that's saying when x is negative 5, y is 0. That is one of your roots right there is negative 5, or one of your zeros. Another name for that is roots. You know, that's where the graph hits the x-axis and stuff. So that has if it's on the x-axis, zeros, roots, on x-axis. Therefore, y equals 0. So we found one of them. They gave us one. The fact that it's a power 3, meaning that 3 is the highest exponent. It is an odd function, so the arrows will be ending in different directions. It's an odd power. It is not an odd function because it also has even exponents. Remember, even functions have all even exponents and symmetrical on the y-axis. Odd functions have all odd exponents and are symmetrical about the origin, like a 180 rotation. But anyways, not really what we're talking about here, but of course related. So how do we find the other roots? Well, one of our obstacles is we're missing a coefficient. They're giving us that bx squared. And so I can't really type into my calculator this function, or I can't factor it. I can't really do anything unless I figure out what b is first. So that's our first obstacle, is to find b. And the way we could do that is with one of these two solutions they gave us. We can replace, z of x with one of these. Oh, let me show you what I mean. So z of x is the same thing as y, right? Like f of x is y equals, so it's like y equals this whole thing. So I can use this point, z of 2 is 35, to say that 35 equals 6 times 2 cubed plus b. I'm going to try to make my b's not look like 6's, but try to remember that that's a b there. B times 2 squared minus 52 times 2 plus 15. Now, so what did I do? I replaced the y with the y value of 35, and I replaced all three of the x's here with the x value of 2, because if this point's on this graph, then these are the values of x and y that make it work. And so by replacing x and y with values I know of for x and y, the only variable left in here is this b. That's a 6. I could do the same thing with this one over here. That would give us, now it's just not necessary. Let me write this over here real quick. That would be 0 equals 6 times negative 5 cubed plus b times negative 5 squared minus 52 times negative 5, and I'm definitely running out of space, plus 15. Now, the reason why I'm just kind of writing this over here off to the side is because I could just use this one. I don't need both of those things, so I'm just going to erase that just so it's out of the way. So pick one. You could use either one of them. I will actually be using this for something else later, but I'll get to that. So let's solve this. Well, that would be 35 equals 6 times 2 cubed is really 6 times 8. 6 times 8, 48. Plus 2 squared here is 4, so this would be plus 4b minus 104, that's our 52 times 2, plus 15. And so let's clean this up a little bit. What are all these numbers over here? We got 48, negative 1 over 4, 15. We'll use a calculator so I don't make any mental math errors over here. So let me clear out some old work here. 48 minus 104 plus 15 is negative 41. So we have 4b minus 41. And so I'll add that 41 over, making that a 76 equals 4b. And then lastly, I'll divide by 4 to get my annoying little b value. 76 divided by 4. So 70, oh, I got to tap on that first, sorry. Get rid of that. 76 divided by 4 is 19. So B is 19. Now, the question doesn't say find B. It says find all of the roots. So we have to do that. But now that we know what B is, we can continue there and go forward with that. So let me rewrite this now without B, but with 19. So that means that Z of X, what this function really is 6x cubed plus 19x squared minus 52x plus 15. All right, and I want to know all the roots of that. Now, um, first, 4 terms, so if I cut it in half, can I factor it? Well, the only thing I could take out here would be x squared, and I'm going to get 6x plus 19. I'm not going to get that from factoring over there. So it is not a factorable expression, which means that one or more of the roots is either imaginary or irrational, or maybe it's just something that's annoying that can't be factored, and that does come up sometimes. Um, so, so let's see. How can we figure this out? Well, we do know one of the roots, and one of the nice things about that is when you know one of the roots or one of the zeros, if you divide it away, the term that's left over is comprised of the remaining factors. So what we can do is we could use synthetic division to take this -5 out. And then when we take it out, we'll be left with just like an x squared expression, and maybe that'll be factorable. If not, we'll look at our calculator and see what happens. Now, if you didn't know that -50 was one of the roots, now that we do have the whole thing, I could, try to get the roots solely from the calculator, and let's see what that does. What is it? 6x cubed plus 19x squared minus 52 x plus 15. And let me just delete this other equation that was there. And let's take a look. Here we go. There's one root. There's another, and there's another. So I could take a look at my table to see if I have any y values of 0. And we do get, oops, sorry about that. We do get one y value of 0 right there at -50. Again, we knew that, but you could sometimes get it from there. The other option is to use our friend Toodles with second calc, which gives second trace brings us to the calculate folder, and if we choose 0, choice 2, and we have Toodles here, so right now I don't see him, but it's telling me where he is. He's at 0, 15. So if I go, let's go to the right a little bit. There he is. If I want to find out what this root is here, I'm to the left of it right now. If I hit enter, I move to the right of it, enter, enter. It tells me it's 0.3 repeating, which I know is equivalent to 1/3. So one of my other roots is going to be 1/3. Now I could do that for the other one, but the problem with using our calculator and our friend Toodles there is they want us to algebraically determine all the roots. Now, if this is a part 3 Regents question and I got all the roots from my calculator, I am going to get 1 point for that. But I'm not going to get anything besides 1 point because the work on these questions is worth more credit than the actual final answer. Because they know you could probably get it other ways with your calculator or from cheating or something from that. So how would I do this algebraically? Well, again, I want to synthetically divide, or long division, but synthetic division is a lot easier. Divide out the one root I do know, -5. And I know this because they gave it to us. And so 6, 19, -52, and 15. And so we'll go through the process of synthetic division. Remember, we just write them without variables. Make sure there's no holes, like there's no missing 0x squared or something that should be there, because you got to fill that in with a 0 if there is. And this -5 is a 0. It's not a factor. The factor would be x plus 5, and that's what we would use for long division. That's the difference between a factor and a 0. Because when you set a factor equal to 0 and solve, you get the 0. But synthetic division uses zeros or roots. Long division uses factors. So I could divide this by x plus 5 in long division. But again, synthetic's a little bit quicker. So bring down the 6 times -5. Excuse me. And so that would give us -30. And then when I add these together, again, I get -11. times a negative 5 is positive 55. Add these together to get 3, times these together to get negative 15. These add to be 0. Now, I did that quick, but this isn't really a video on synthetic division, so if you don't know how to do this process, I strongly recommend looking it up. It's going to make your life easier. This last 0 is very important because that's the remainder one. These 3 are going to become coefficients in my new term, but that 0 is the remainder, and that had to be a 0. Because for this to be a 0, it must have a remainder of 0, a y value of 0. So that's really important that that matched up, because if this wasn't 0, then this is trash. But it is, so we're good. Now, because I started with an x cubed as my highest power, by taking out 1 0, that would make this then an x squared, an x to the first, and then a plus 3 as a constant. So I have a new function, 6x squared minus 11x plus 3. And I'll set this one equal to 0 and see if I can maybe factor this. Again, I can look at the calculator for help, but again, like I said, that's not going to really give me an acceptable algebraic solution. So the big hint here, the fact that they want you to solve algebraically, is that this can be done on paper without a calculator, but not factorable yet. But once I take out that number, this is going to be factorable. And it's going to be AC factoring. So I multiply the first times the last. 6 times 3 is 18x squared. And I need something that multiplies to that and adds to negative 11. And let's see, 18, 9, and 2. They're both going to be negative. So this splits to be negative 9x and negative 2x. They add to negative 11, and they would multiply to positive 18x squared. All right, bring down the front, 6x squared. Bring down the back, plus 3. And now I do my factor by grouping process. Cut it in half. Over here, we could take out a 3 and an x. I get 2x minus 3. Over here, there's really nothing to take out. When there's nothing, you got to take out at least a 1, and you always take out the same sign as the first piece. So I'll take out a negative 1. And that'll leave me with a quotient of 2x minus 3. And that's important because this quotient has to match this quotient, because they get factored out, 2x minus 3, and the GCFs combine to be 3x minus 1. Still set equal to 0. So last thing I need to do is solve each of these individually. I'll set 2x minus 3 equals 0 and 3x minus 1 equals 0. Add the 3, divide the 2. So x equals 3 over 2. Here we will add the 1, divide the 3. And so that is where that 1/3 came from. So the solutions are x equals 3 over 2, 1 over 3, and the negative 5 that we had in the beginning of the problem. That needs to be included as well. So that's it. And again, now I can use my calculator in Toodles to test this. Now 3 over 2 is equivalent to like 1.5. So let's say second calc 2 for the 0 option. Move Toodles over to this other spot. Got to be to the left of it, enter. To the right of it, double enter. And hopefully I get a x equals 1.5. And so that is equivalent to 3 over 2. All right, so that's it for sample number 15. Some long division, some synthetic division, some factoring. It's a good question. Has a lot of algebra stuff in there, so make sure you know how to do all of that.